This is a question that I have given for both of you, and I think both of you can do this. How many answer? So C3H6N is your amine, and C3 is there, so I can write like this: CH3CH2. 1 degree amine is this, and then I can write 2 degree amine as well. NH is there, not NH2 is there. NH is there. Then I can also write like this 3 degree amine as well. And then I can also write like this CH3CHNH2 CH. Is that clear, both of you? So the answer will be for this. I think it's easy, right? Please do respond. Am I not audible to both of you? Huma? Okay, thank you. So basically, we are going to finish this chapter almost. Let's see. In the next class, Huma, are you there?
Yes, sir.
Okay. So I'm going to introduce this chemical reaction. Chemical reaction, first we have basic character, which we will study at last, which is very important. And most probably there will be questions on that basic character because it varies. There are other factors that comes into play. That's why it is important. Like in inorganic chemistry, you know, the exception always rules the question. So in that way. So in the first, when we are going to talk about this chemical reaction, first we are going to talk about alkylation. So the first chemical reaction is your not alkylation. I'm going to introduce acylation first, which is very easy to understand. Alkylation basically we already studied, but at the end of this topic, chemical reaction, I'll tell you. So see, acylation, either it is aliphatic amine or either it is aromatic amine. And aromatic, primary or secondary, not for tertiary. It is not for tertiary. Primary and secondary amines react with chloride, acid chloride, react with acid chlorides. So see how it is going to react. Very simple it is. Let's say I'm going to take C2H5, that means CH3CH2. And first I'm going to take this as primary. So this is your primary amine and it is going to react with acid chloride. So let's say this is your acid chloride. There is CH3 and there is C double bond. So you know that this is your acid chloride or acyl halide if you are going to write X at the place of X. And this reaction basically occurs in the presence of base. In the presence of base. Now what will happen? Very simple. This is a carbonyl compound. So this will be taking its carbon's electron. So there will be deficiency of electrons. So this nitrogen will be attacking on this carbon. well as O negative is there because oxygen gain the electron of carbon, right? After this, what will happen? You know that most negative, basically more electronegative element, if positive charge is there, it is unstable. So in order to stabilize itself, what will happen? This nitrogen will take electron from hydrogen to stabilize itself. And this chlorine is a living group, so it will leave this scenario compound. So what will be the product that we will get? C2H5N. H is there and then CCH3 is there. When chlorine will leave the carbon with carbon's electron, basically in the form of Cl minus, this negative charge again comes into double bond and it becomes amide. And its name is N-ethyl ethanamide. So in the first step, carbonyl group C double bond O will gain the electron. So carbon will have electrophilicity on which nitrogen will attack with its lone pair. So now nitrogen has positive charge. So it is unstable. In order to get a stability, nitrogen will take electron from hydrogen. And it will be like this. And chlorine is a living group. So it will leave it. So this scenario will be the same. Please do write. In the same way, the reaction occur for secondary. Let me know when you are done with this. And write it a little faster. Are you done with this?
Yes, sir.
Okay, so try to apply the same mechanism for this. This is your secondary C2H5. N is there. C2H5 is there. Lone pair, you know there is lone pair. Hydrogen is there. And you are going to do the same thing. C double bond O. CH3 is there and Cl is there. And the reaction is occurring in the presence of base. Are you done with this? So see what will happen, very simple. This will be going like this. So this will be attacking on this. So what we will have, C2H5, N is there, hydrogen is there, C2H5 is there. Now you know that this is attacking on carbon, so carbon is there, and CH3 was there, and this becomes O negative, and there is Cl. Now you know that there is positive charge which is unstable. So in order to get a stability, this will be taking its electron, this will be living like this, and this will be going like this. Okay, so this becomes N, C2H5, C2H5, and then C double bond O, and then CH3 is there. And it has a name. There is 2-ethyl, 3-ethyl is there. So again, I'm gonna write N comma N, diethyl ethanamide. Is this clear, Humamudin?
Yes, sir.
Please do write it. Let me know when you are done with this.
Done.
Very good. So this was the scenario for this. Now the next reaction is also very easy. If you are going to react with anhydride, so if you have this say, C2H5, or either you can take C6H5, C6H5, NH is there, and you are going to react this with anhydride. Anhydride is acidic acid anhydride. I'm talking about C double bond O, O, C double bond O, CH3. Peroxide is there. So how the reaction will take place? So nitrogen, hydrogen, this is positive, this is negative. Between carbon and oxygen, this is negative, this is positive. Hmm. Just wait a minute. It's going to be with negative, this positive will come into play. Okay. And with this, okay. No oxygen is there. Just wait a minute. Just wait a minute. It will be wrong. Now see what will happen. This is a scenario. Okay. Okay, very simple it is. First, I'm going to write the product, then I'll show you how you are going to do it. C6H5, NH is there, so I'm going to write C6H5, NH. One of the hydrogen will be lost in the form of H plus, and it will be directly connected with this carbon. Basically, this will take its electron, so it becomes H positive, and this becomes negative, right? So this will be coming into place, C double bond O, CH3. Okay. Now, what will happen between this CH3 and C double bond O is there. So this becomes CH3 C double OH. Just write it again. I'll explain. So this has a name that is, we can write ethanoic anhydride. And this has a name, N-phenyl. I'm writing the name of this, N-phenyl ethanamide. Or it has a common name that is acetinylide. Acetanilide. And you can write the structure as well. That, oh, wait a minute. You can write the structure like this as well. And H is there. C double bond of CH3 is there. So in phenyl like this. Anhydride, just wait a minute. Did I? Oh, here I made a mistake. CO only these there. I wrote it peroxide. Yes, this is your anhydride. Basically, I wrote peroxide, which is wrong. That's why I got confused. So see how you are going to do. Very simple it is. This has negative, this has positive charge. This has positive, this has negative charge. So this negative will be attacking on this. So what you will get C6H5NH, and then this becomes C double bond of CH3. And here H plus will be attacking, so it becomes CH3 C double OH. Is that right? Is that clear? Both of you. Let me know when you are done with this. Are you done with this, Umam?
Yes, sir.
No. Now there are other type of reaction in this. This amines also reacts with benzoyl chloride, benzoyl chlorides. Benzoyl chloride, that means benzene and connected with acyl halide or acyl chloride, you can say. This is a common name for benzoyl chloride. And this reaction is known as benzoylation. This reaction is known as benzoylation. Okay. So how the reaction takes place? Very simple it is. If you have this amine CH3 NH2 and you are going to react this with C6H5COCl, the first reaction that we did, basically what will happen, Cl will be the leaving group in the form of negative because it is connected to carbon, and one of the hydrogen from here will be eliminated like this, CH3. The first reaction that we did for acylation is the same as this, and can I write like this, CH3 C double bond O CH3, and you can remove this HCl. and you can add this together, so it becomes CH3NH, because a nitrogen still have one hydrogen, COCH3. So this is what you will get, and it will have a name, N-methyl. Just wait a minute. It will have a name, N-methyl ethanamide. Is that clear? In the same way, the reaction took place here. I made it lengthy, but if you are going to see, I can write this reaction in this form. Like you can see C2H5, I can write, and hydrogen is here, and C2H5 is here, and I can write like this C double bond O CH3, and you can remove this HCl. Are you getting my point? You will get the both this product, sorry, this product, right, directly. Are you getting my point, both of you?
Yes, sir.
So in the same way, you can write this. Very important reaction, this benzoylation. Very important. Let me know when you are done with this. Both of you.
Done, sir.
Very good. Okay, okay. AJ, let me know when you are done with this. Okay. Now see. Then comes your carbolamine test, which is very important. Next part is your carbolamine test. This is very important. Make a list of all the tests in organic chemistry, which is very important. Okay, just wait a minute. So basically, see, this carbolamine test, it is either aliphatic or aromatic. It should be primary amines, not secondary and tertiary. Primary amines on hitting with chloroform CHCl3, and ethanolic potassium hydroxide forms isocyanide or carb carbyl amines or carbyl amines, which are foul smelling. They can directly ask you about foul smelling, so you have to understand that it is isocyanide or carbamines, foul smelling substances. And this reaction is known as carbylamine reaction or isocyanide test or isocyanide test, and it is used for primary amines. It is to test used as a test for primary amines. So please do write it first, then I'll show you the reaction as well. Are you done with this? Humam,
That's it.
Now see how the reaction will take place. First, you are going to take a primary amine. So this is your primary amine. And if you are going to react this with chloroform, that means CHCl3 in the presence of this ethanolic potassium hydroxide. And if you are going to heat it, to balance it, I'm going to write it here 3 moles of KOH I'm going to take. 3 moles of KOH. Now, what will happen? Very simple it is. This will be converted into RNC. See, cyanide is RCN. The alkyl group is connected with carbon, and here it becomes RCN, or you can write R. CN has triple bond already between this, and since nitrogen is making 4 bond, it will have positive charge along with byproduct KCl plus 3H2. And this isocyanide is your foul smelling substances. Is that clear? If you have something like this is also a primary. You know that this is your primary. And if you are going to react this with the same thing, like CHCl3 and KOH, and you are going to heat it, this will be converted into NC. Is that clear? And please let me know about this product 1, 2, 3. First, you are going to react this with Br2 in the presence of KOH. Then you will be getting A. And then you are going to use CHCl3 in the presence of KOH and heat. Then you are getting B. Let me know when you are done with this. The reactions in this chapter is very, very easy. Are you done with this?
Yes.
So after carbonyl, we have a reaction with nitrous acid. That means NaNO2 in the presence of HCl, or you can directly write HNO2. So the next reaction is a reaction with nitrous acid. Now, see what happens in this. Very simple it is. It reacts in different manner with primary, secondary, and tertiary way. I will show you. Primary amines react with nitrous acid to form aliphatic, to form aliphatic diazonium salt. Aliphatic diazonium salt. Please do write it. So basically, aliphatic diazonium salt. Diazonium is basically N2 plus. It is a functional group. Okay, connected with any ring or any alkyl group, that is your diazonium. And aliphatic diazonium generally it is unstable. So I just wrote it this. When primary amines is going to react with nitrous acid, it forms aliphatic diazonium salt, which is being unstable. It is unstable. So basically, in order to get a stability, it will liberate nitrogen gas. So I can write. So it liberates N2 gas. N2. Quantitatively. And alcohols. So I can write a reaction. RNH2 is going to react with HNO2, HNO2 nitrous acid, or you can say this is in the presence of NaNO2 plus HCl. So this nitrogen will go and it forms Rn2 plus Cl minus. Here it will be like this. And after hydrolysis in the solution, this will be converted into ROH along with N2 and HCl. So whenever a primary amine is going to react with nitrous acid, you will get diazonium. If you are going to use primary amines like this without benzene, you will be getting this diazonium chloride, which is a salt and being unstable. It will be broken down into alcohol, HCl, and nitrogen gas. But if this reaction, the same reaction you have studied in halogens and halogens, in which we had prepared halogens by Sandmers, amines by Sandmers, if you remember, Sandmers reaction. So this is how in primary amines it takes place. In aromatic, you will see what will happen. Basically, in aromatic, what happens due to resonance, it is stable. So the next step does not take place. And secondary, tertiary react in different manner. Very simple it is. You know when you are done with this. Are you done with this? Mom?
Yes.
No. Now the next is we are going to talk about B. That is your aromatic amines. For aromatic amines. You know, in aromatic amines, we already studied this reaction C6H5 when it is C6H5NH2. It is your aniline, if you remember. Aniline, that means benzenamine. You can write the structure like this, then maybe you are able to remember this. Now, when you are going to react this with NaNO2 in the presence of HCl, and the temperature was 0 to 5 degrees centigrade, that means 273 to 278 Kelvin. What will happen? Benzene diazonium chloride will form. N2 plus Cl minus will form along with NaCl along with 2H2O. And in that chapter, since we studied, wait a minute, benzene diazonium chloride, since we were studying the preparation of haloarenes, so we treated this with Cu2X2 something, and you get this X directly or chlorine directly connected to this. Do you remember that? That was your Sandmeyer's reaction. Is that clear?
Yes.
Please do write this. Plus M is ortho and para directing, minus M is meta directing, right? Are you done with this?
Yes.
Okay. Now the next reaction comes out to be reaction with aryl sulfonyl chloride. Very easy reaction it is, in the same way that we did for acyl halide. And there is a statement, please do write with me. Benzene sulfonyl chloride. Benzene sulfonyl chloride, which has a formula C6H5 sulfonyl chloride, that means SO2Cl, which is also known as Hinsberg reagent. Hinsberg's reagent. And it reacts with primary and secondary amines. Reacts with primary and secondary amines to produce or to form. Wait a minute. It reacts with primary and secondary amines to form sulfonamides. So see how reaction will be taking place. First, I'm going to write the structure of this. This is your benzene sulfonyl chloride, and this is with the primary amine. There will be 2 hydrogen in amine. You know that this is your C2H5. So how the reaction will be taking place? You are going to remove this HCl, simple, and connect this, so it becomes sulfonamide. S double bond O, then N, then H, and then comes your C2H5. That means CH2CH3 you can write, or C2H5 you can write, and HCl. And this has a name, which is, you can see N-ethyl is there. This will be your branch. N-ethyl benzene sulfonamide. Benzene sulfonamide. And it is soluble in alkali. This is very important point. You know, there will be another reaction that we will see. So this reaction is basically, this is your Hinsberg reagent. This reagent is called Hinsberg reagent, and this is for primary. With primary, for primary this is. For secondary I will show you. And it is a soluble. In primary you will get a soluble. It will be soluble in alkali. Please do write it. And with secondary, whatever is going to be formed, whatever is going to be formed, that will not be soluble in alkali. Let me know when you are done with this.
Done.
Very good. So this was about benzene sulfonic with the primary, and for secondary with the secondary. I'll show you. With the tertiary, it is not possible because nitrogen will not have any hydrogen. So we are directly going for secondary. And in secondary, this is the scenario. S double bond O, Cl is there. And in secondary, it will have only one hydrogen along with two alkyl group. So what you need to do, very simple. Just remove this HCl and add them. What you will be getting, this is what you will be getting. N comma N diethyl. S double bond O and double bond O. And this will be directly going to connect with N C2H5, C2H5. And it has a name N comma N diethyl benzene sulfonamide. Insoluble in alkali because it doesn't have any hydrogen. And with tertiary, it doesn't react. It doesn't react with what? C6H5SO2Cl, right? SO2Cl. Oh, wait a minute. Did I write SO there or SO2? Wait a minute. SO2 I have written. SO2Cl. So this can also be used to determine or test for primary, secondary, and tertiary. If you're going to react with primary and it is soluble in alkali, that means it is primary. If you have an amine and which is going to react but it is not soluble in alkali, that means it is secondary amines. And if you are going to use tertiary, it won't react. So it is tertiary. Are you getting my point, both of you? Are you done with this?
Yes.
Okay. Now the next reaction type is your electrophilic substitution reaction. So you can write electrophilic substitution reaction. So in this we have the first one, that is your nitration. Sorry, bromination. We are going to start from bromination. So halogenation we have already studied. In this chapter we are going to specifically talk about bromination. That means bromine you need to add. Now the reaction is taking place like this. See, NH2 is there and you are going to take 3 moles of Br2, or you can say basically you are taking bromine water. That means lots of Br will be there, and NH2 is generally your NH2 is plus M effect. So what will happen? It is ortho and para directing. So bromine water is there. So lots of Br will be attached. That means it will be attacking at second position, ortho, fourth position, and sixth position. So you will be directly getting 2, 4, 6 tribromo aniline. This is the product you will get. But if you want that only one bromine you should be in this, you should have in this way, there is another way to make that with the help of another reagent. So we are going to do that as well. First, write it. Are you done with this?
Yes, sir.
Okay. Now, in order to get only one bromine there, I can use this bromine. This is your NH2. You are going to use this peroxide CH3 COO whole twice O in the presence of pyridine. What will happen? Very simple. This whole quantity will be replaced by one hydrogen. So it becomes amide like this. See, there is NH only left. One of the hydrogen is replaced by C double bond O CH3 with this. Okay. After this, you are going to use Br2 in the presence of CH3 C double OH. So as you know that this has a lone pair which is plus M effect, and plus M effect is your ortho and para directing. So here I'm going to directly write this product. NH is there, C double bond O is there, and CH3 is there, and bromine will be directly attached on para, and this will be your major product. It will be attached to ortho as well, but there is a bulky group at this position, so it will be minor. Due to repulsion, it will be unstable. After that, you are going to use OH or H plus, OH minus acid or base. So this whole quantity will be eliminated, and this H plus will be going to attach with this. So you will be getting 4-bromoaniline or para-bromoaniline. Bromine is there. So we can write 4-bromoaniline. This also has a name that you already know. Aniline is there. This also has a name that is N-phenyl ethanamide, which has a common name, acetanilide. Then I'll send you a PDF and written biomolecules. Very easy it is. Let me know when you are done with this. Are you done with this?
Yes, sir.
Now the next is your nitrogen. See what happens in nitrogen. Again, you are going to use this NH2. That means aniline. And for nitration, what do we use? HNO3 and H2SO4. And temperature is 288 Kelvin. So see what happens here. Very simple and very important. You will get, how many products. What I told you before that this NH2 is your plus M effect. That's why it is ortho and para directing. But here, when you are going to see the product, you will be getting this product NO2. Basically, what happens in this from this, you will be getting an electrophile NO2 plus, which will be attacking on para, which is 51% in quantity. That means it is major product. Then comes your meta as well. This is very important. NO2 will be attacking at meta as well, and it is your 47%. And then comes your ortho, and it is only 2%. So why it is so? Why it is being meta? Only because when NH2, if you're going to see NH2, this is I'm going to write pH. NH2 is there, and in the presence of a strong acid, okay, strong acid is there. That means H plus will be there, and this will be attacking this, or lone pair will be attacking on this, and you will be getting NH3 positive, which makes it minus M. Are you getting my point? So usually it was plus M, in which this will be the most stable. Okay. After reacting with the reagent, it attacked by H plus. So it becomes minus M and hence it is meta directing now. Are you getting my point, Austin? Umam, Umam, are you there?
Yes, sir.
Please do write it. So this is very important. They can ask you why in this NH2. It is meta directing. So due to the presence of acid, proton, due to the presence of proton. Let me know when you're done with this.
Done, sir.
Okay. Now, if you want a very good percentage of this measure, since it is 51%, that means almost 50%. So how can you get? In the same way that we get from that we get in bromination. Like this is your aniline. So first you are going to react this with again CH3CO, whole twice O, in the presence of pyridine. In the presence of pyridine. Now what will happen? One of the hydrogen will be replaced and it will be converted into this NH and then CO, CH3. Okay. After this, what you need to do? There bromination was taking place, and here we need to do nitration. So we are going to use HNO3 and H2SO4, and the temperature is similar. Now NO2 plus will be generated, and it will be attacking. See where it will attack. It will be attacking at ortho and para. Para will be the major, and since we need aniline, so again you are going to dip this in acid or base, and this whole quantity will be converted into carboxylic acid, and this will be converted into 4 nitroaniline. 4 nitro, and I think it's clear, right? Let me know when you are done with this.
Done, sir.
The last one comes out to be sulfonation in this electrophilic substitution reaction. Sulfonation, that means sulfonic acid you are going to add. So for sulfonation, you are going to use this. We are studying amine and H2 is there. So first you are going to use H2SO4. And you know H2SO4 is going to release H plus that will attack NH2. NH2 is there, H plus released. So this will be attacking and it becomes NH3 positive. And since H2SO4 released H plus, it becomes HSO4 minus, right? So minus plus, this makes an ionic bond, an ionic bond. So this will be NH3 positive into HSO4 minus. The bond between NH3 positive and HSO4 minus is ionic. And after this, you are going to heat it 453 to 473 Kelvin. And this will be something like this. NH2 will be there and SO3H. Shifting will be taking place. Or it can be like this. SO3 negative since it is acidic and this becomes NH3 positive. And this has a name that is sulfonilic acid. Sulfonilic acid. And this is your zwitter ion. And you are going to heat it, the whole quantity will be eliminated. And this has a name anilinium hydrogen sulfate. And always remember that aniline does not undergo Friedel Crafts reaction. So whether it is alkylation or whether it is acylation. Whether it is alkylation or whether it is acylation. Why it is so? Because of salt formation. That Cl will combine with that and make a salt due to salt formation, only because of salt formation with ammonium chloride. Very important point this is because generally students think that NH2 is positive, sorry, plus M, so it will go, but this will not. Let me know, I need to add point in this chloride. Two is acid, which is used as a catalyst. And there will be positive formation on nitrogen, which will be acting as a strong deactivating group, not activating group. Are you done with this? Yeah, very good. So this is it for today. I'll see you in the next class.
Done.
Okay.